One of my favorite things about molarity, and I think what I really like about molarity, is that we can use it as a conversion factor. So we have a solution that is, say, 0.2 molar in glucose. We can go ahead and say that that actually means that there are 0.2 moles of glucose in every 1 liter of that solution. And so I love conversion factors because they make conversion problems super duper easy. Give you an example, right? So we might go ahead and we might want to say, if we had, say, 0.38 liters of this solution and we want to know how many moles of glucose, we can go ahead and set it up as a conversion factor problem. So we've got our 0.38 liters and we multiply by the correct conversion factor. So what's the correct conversion factor, right? Because we've got two things. We've got the 0.2 moles of glucose and we've got the 1 liter of solution, and only one of those can go on the top, but the other one's got to go on the bottom. So if we pick the correct factor, then it'll be obvious that we need the liters to go on the bottom, because the liters have to cancel out because they're naughty, and that gives us the moles on the top. They're moles of glucose. And let's go ahead and strike out those liters of solution. That gives us moles. And my calculator says that is 0.0, so nothing significant yet, 76 moles of glucose. So we can go ahead and we can find the number of moles in a volume by using this as a conversion factor. We might want to go the other way. So maybe we want to say, well, gosh, I actually don't want 0.076 moles of glucose. I want 0.086 moles of glucose. So my question is, what volume, so how many liters of the solution are we going to need to do this? And we can do this using conversion factors again. So we go ahead and we start by taking what we want to convert. So that is the 0.086 moles. And those are moles of glucose, so there we go. And we want to set this up as a conversion factor. So we want the moles of glucose to cancel out, and we want liters to appear. So we have to take the moles of glucose to the bottom, and we have to take the liters of solution to the top. So we can do that. So our 1 liter of solution goes on the top. Our 0.2 moles of glucose goes to the bottom, and we can see that the moles of glucose cancel right there. And we're left with liters of the solution, and we can go ahead and crunch this on our calculator, and our calculator gives 0.43. So for once it actually doesn't lie. It's got the number of significant figures right. Even though my calculator doesn't say units, I know that they must be liters. So we've got 0.43 liters of solution. If you were in the lab, you probably would measure that out in milliliters. And if you remember that a milliliter is 1,000 liters, that corresponds to 430 milliliters. You can set it up as a conversion, or you can just shift the decimal 3 times if you prefer.